current electricity. So till now we have learned about the current I, which is basically nothing but the flow of charge, right? We have learned about the potential, okay? The relation between current, potential, and resistance, which is basically a Ohm's law, okay? So this was the thing. Now we are going to solve some questions, okay? And then what happened? Is it visible, the screen?
Yes, sir.
Okay. So let's take another example, which is saying, question is, the potential difference, the potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential is increased to 120 volt? So this is the question. Any idea how we are going to solve this? Hmm?
Well, the watts will be 60 right now, and ampere will be 4. So then you have, it's
Okay.
increased. The new watt will be 160 or 120. Okay.
First of all, what we are going to find out here? What is the question? What current?
We have
Okay, we need to
current.
find the current.
Yes, sir.
Okay. So the information given is the potential difference between the terminals of an electric heater is 60 volt. Potential difference is given, which is 60 volt. When it draws a current of how many amperes? Let's say I1 is equal to 4 amp from the source, right?
Yes.
Now the question is, what current will the heater draw if the potential increase to 120 volt, right? So we need to
Yes, sir.
find the, here the new potential is given as 120 volt. And we need to find this current I2. This is the question, okay?
Yes, sir.
And we already studied the Ohm's law, which is V is equal to IR, right?
Yes, sir.
And here the question says that the material remains same, right? There is no mention of changing a material. If the material is not changing, that means the resistance is same for both the cases.
Yes, sir.
Okay, so first of all, we are going to find out the resistance. So from this expression, resistance, we can write it as V upon I, right? Here,
Yes, sir.
potential is 60 and current is 4.
Yes,
60 by 4 is nothing but 15
yes,
ohm,
sir.
right?
Yes, sir.
The resistance is 15 ohm. We know that the unit of resistance is ohm, right? Sorry.
Oh, yes,
Now,
sir. Yes, sir.
now we have the resistance.
So I2 is 8 amperes.
Again, V is equal to IR, which is basically V2 is equal to I2R. From here, I2 we can write it as V2 by R. That is nothing but
Yes,
120 by 15. And 120 by 15 is how much? 8 ampere. So our new current will be what? 8 ampere. Any question? Hello.
no, sir. No questions.
Okay, write this down. I'll give you a 2 minute. Okay.
Yes, sir. Yes, sir. Done.
Ishan done?
Yes, sir. Yes, sir.
Okay. Let's move on to another question, which is the statement of the question is the potential difference. The potential difference. We are going to write potential difference as PD, okay?
Yes, sir.
Between the terminals. Okay, sorry. Resistance resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Okay, so here we
Yes,
need
sir.
to use the table, okay, which we did not discuss about it because there will always be data given to you if the question is asked for this type of question, okay, so no need to worry about it. First of all, what we need to find here? The question says the resistivity, right? What will be the resistivity? What will be the resistivity? And you know what is the formula of resistivity? Rho is equal to what?
The
Formula of
rho is
resistance.
equal to
eh?
R times A by
Ra upon
R.
L. The resistance
Yes.
was rho L upon L. Okay.
Yes,
So
sir.
here What is given? Resistance is given, which is 26 ohm. Okay. What else is
Yes,
there?
sir.
Diameter is also given. Diameter D is
Yes,
0.3 mm. That means its radius is 0.3 by 2 millimeter. Okay.
yes, sir.
Since it is a wire, so the area of this end is basically a disc. Okay. This looks like a disc. Basically, area of this wire will be what, pi r square or not? Yes or no?
Yes, sir.
So
Yes,
the
sir.
area becomes pi r square, which is nothing but pi into 0.3 by 2 whole square. That means pi by 4 and 0.3 whole square gives us what? 9 into 10 raised to minus 2, right?
Yes, sir.
You know well, right? How to write fraction in form of the power of 10.
Yes, sir. Yes, sir.
Okay, so no problem. Okay, so the area is here, resistance is here. Okay, what else we need? The
We need
length.
to find the length in
Length is
the
given.
millimeter.
Length is 1 meter. So
Yes, sir.
question becomes very easy. RA upon L. Resistance is 26. Area is 5 by 4 into 9 into 10 raised to minus 2. And length is 1 meter. Which is basically 13 2 za 26. 2 2 za 4. That means 13 by 2 into pi into 9 into 10 raised to minus 2. 13 by 2. Pi is what? 22 by 7 into 9 into 10 raised to minus 2. And this will finally gives us the solution, which is 1.84 into 10 raised to minus 6 ohm. That will be our answer, right?
Yes, sir.
Okay, so write this down. We are moving ahead, moving forward.
Yes, sir.
Okay. Any question regarding this question? Problem?
No, sir.
Okay.
No, sir.
Another question. It says a wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of wire of the same material? Sorry,
Yes, sir.
of the same material having length L by 2 and area of cross section and area 2 capital A. We need to find the new resistance. So try this out and let me know if you are getting the answer.
So 16 ohms.
16 ohms. I
Yes,
think
sir.
you calculated wrongly or you have made some mistake. Answer is 1 ohm. Why you are
1
getting
ohm.
16 ohm?
1 second, sir. Yes, sir. 1 ohm it will be.
Okay. Again, let me do it. Okay, and we'll move forward. A wire of given material having length L. Length is L. Area of
Yes,
cross
sir.
section A has a resistance of 4 ohm. Resistance is 4 ohm. What would be the resistance of the wire of the same material having length L by 2 and area 2A? So for this material, there was no resistivity is given, right?
Yes, sir.
Resistivity was missing. So first of all, we are going to find the resistivity, which is given as RA by L, right?
Yes, sir.
Okay. And the other thing given is what? What would be the resistance of the wire of the same material having length L by 2? So new length L2 is what? L by 2. And new area A2 is what? 2A, right?
Yes, sir.
Since it is the same material, so resistivity will remain same, right?
Yes, sir.
So for this row, we can write it as uh, R. This is R1. This is R2 A2 upon L2, right?
Yes, sir.
Now what is R2 that we need to find? Okay, what is A2? Simply 2A. And what is L2? It is L by 2. So by simplifying, we'll get 4 R2A upon L, right?
Yes, sir.
Okay. But this is our row. So we can simply compare these two equations, right? Because this is the same material, so resistivity is same. So we can compare this RA upon L is equal to 4 R2A upon L, right?
Yes, sir.
So L gets cancelled out and we get R1 is equal to 4 R2. Since R1 is what? 4 ohm, right? R1 was 4 ohm. So 4 is equal to 4 R2. So R2 is nothing but 1 ohm. So this will be our answer. Do not forget to write this unit, okay?
Yes, sir.
Examiner can cut your marks. So please don't forget these things. These little things are very important. So those are the three examples. Okay, there are many examples, but right now we will move forward on the topic known as resistance of system of resistance. Resistance of a system of resistors.
Yes, sir.
Right? Okay. So till now we have discussed about one resistance, current, voltage, okay? But there was no two resistance or many resistances, right? So what if there are two resistors in the given circuit? What will happen? How to add resistors? How to subtract resistors, right? So these are the questions that needs to be answered. So there are two type of connection we can do with the resistors. Okay, first one is known as series. Series. What is the spelling of series? Totally forgot. Series combination, and second one is parallel combination.
Yes, sir.
In series combination resistance, we simply add these resistors linearly. Okay, this resistance is R1, R2, R3. Are you getting my point?
Yes, sir.
We add resistors linearly. For parallel combination, we add resistors in this way, not linearly but parallelly. Are you getting my point?
Yes, sir.
So, what is the difference between these two combinations? Let's discuss first of all. So, what happens when you connect a 10-volt battery to this combination? This is the positive side, this is the negative side. Current starts from positive to negative, right? So let's say I current is flowing in this circuit. So this current will remain same throughout the circuit, right?
Yes, sir.
Okay. There is no breaking of this current. Like a river
No,
is
sir.
flowing, but there is no any branches of the river, right?
Yes, sir.
But what if we connect the 10-volt battery to this parallel combination? What will happen? Current will start flowing from positive to negative, but here current will get divided in how many? Three, sorry,
Three, is
four branches,
four.
which is
Yes, sir.
I1, I2, I3, I4, okay? So and so on. So in
Yes, sir.
parallel combination, current gets divided, and in series combination, current remains same, right?
Uh, yeah, yes.
Okay, so this is the important point. Current remains same, and for parallel combination, current gets divided, right?
Yes, sir.
Okay. Now, what about potential? So let's first talk about this parallel combination. Okay. So here is 10-volt battery. That means between these 2 points, let's name these point as A and B. Between
Yes,
these
sir.
2 points, the potential will be 10 volt, right?
Awesome.
Okay, that means for all these points, first one, second one, third, fourth, potential is same because they all lie in one vertically. They line here aligned, right?
Yes, sir.
So potential remains same. That you need to remember. In parallel combination, potential remains same. Okay, but in series combination, because of this, all these different resistors, potential gets divided. Okay, it
Yes,
will
sir.
become V1, V2, V3. So in series combination, potential does not remain same, right?
Yes, sir.
So here potential does not remain same. Now why this happens? So because of there are the resistance, this resistance is different from this resistance, R2 is different from R3, all these resistance are variable, right? R1 is having, let's say, 5 ohm resistance, R2 is 3, R3 is 4 ohm resistance. So because of these different resistors, and we know the relation between current, potential and resistance, which is basically V is equal to IR, right?
Yes, sir.
If resistance changes, potential changes or not? Yes, of course it changes.
Yes, sir.
Okay, that's why we get a different potential, right?
Yes, sir.
Okay, so write this down, we'll move forward.
Yes, sir. Done.
Okay, so now how to add these resistors? Okay, since there are two categories to add the resistances. So for series resistance, we simply add these resistors as R1 plus R2 plus R3, right? This is the equivalent resistance. What it is called? Equivalent
Yes,
resistance.
sir.
For what? For series combination, right?
Yes, sir.
And for parallel combination, we write R equivalent as 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. You getting my point?
Yes, sir.
Okay. So let me just give you one example. Two resistors are connected. in series and in parallel. Okay, in parallel they are connected as like this way. Okay, both the resistance are same. Okay, R and R, right?
Yes, sir.
Now you need to find out the equivalent resistor in both the cases. So for series combination, we know that we simply add these two resistors, which is R plus R, which is 2R, right? Easy, understood?
Yes, sir.
And for a series combination, parallel combination, we write the equivalent resistance as 1 upon R equivalent is equal to 1 upon R1, that means R, plus 1 upon R2, that means 1 upon again R. This will give us 2 by R, right? And by inversing, we'll get R equivalent is equal to R by 2. Clear?
Yes, sir. Ah,
Simple? Easy?
ah, ah.
Okay, let me just give you another example. Three resistors are there. One, two, three. All of them having the same resistance. R, R, R. Similarly, for parallel, they are having the same resistance. R, R, R. Okay? Connected with some battery. You need to find the R equivalent for both the cases. Now tell me what will be the R equivalent in both the cases. Derive by yourself. Try it.
Ah, sir. So in the series connection, it's addition. Second one, it's parallel, right?
Yes.
So 1 by R, 1 plus 1 by R2 plus 1 by R3 equals to 1 by R.
For what? First one or second one?
Second,
Second one. Please repeat.
1 by total resistance
1 by R
equal
equivalent is equal to
1 by R1
1 by R1
plus 1 by R2
plus 1 by R2
plus 1 by R3.
plus 1 by R.
Yes, sir.
Then, since
Uh,
they have the same value, we can
so
write
it
it
will
as
be 1
1 by R plus 1 by R plus 1 by R, which is
so it's
nothing
3 by
but
R.
3 by R.
Yes, sir.
That means 1 upon R equivalent is equal to 3 by R,
Yes,
right?
sir.
That means R equivalent is equal to R by 3. Understood?
Yes, sir.
This was simple. R equivalent is equal to 3 R, right? Okay.
Yes, sir.
Now moving on to combination of resistors. The question is like this way. There is one resistance which is R. There are two resistors R and R. This circuit is given. Now tell me what will be the equivalent resistance for this circuit. You want to try it or what?
Yes, I try.
Try.
Same
Hmm?
Sir, R equivalent equals to 2 plus R by 2 plus R square.
R by 2 plus R square.
No, no, no. Whole thing. Sir, equivalent equals to
Hmm.
R by 2 plus R square.
R by 2 plus R square.
Yes, sir.
No, this is wrong. Remember.
Sir, why, sir?
Okay, okay. So first of all, identify what type of combination is given, right? So this
Yes,
is
sir.
the combination of series and parallel. These two registers are in parallel combination, right?
Yes,
Okay,
sir.
are you getting my point? So for
Yes, sir.
this, we are going to find the R equivalent, which is nothing but 1 upon R equivalent is equal to 1 upon R plus 1 upon R, which is 2 by R. That means R equivalent is equal to R by 2, right?
Yes, sir.
So we are going to replace this circuit with this R equivalent, right? So now the circuit
Yes,
becomes, this remains at is as it is. It was R, and instead of this circuit we are going to write this R equivalent, which is R by 2, right?
yes, sir.
So now calculate the R equivalent. It's easy. R plus R by 2, which is 3R by 2. Understood?
Yes, sir.
मजा आया?
Uh,
Okay, write this down. Did you write it? This one also?
yes, sir.
Okay, write this down. We'll move further.
Yes, I don't.
Okay, now try to solve this question. All the resistance are same. Now tell me what will be the equivalent resistance of this circuit.
Yes, I don't.
Okay, what's the answer?
1 minute, sir. I think sir, I made mistake.
No problem, try again.
So is it 4 by R?
You made a silly mistake. Your approach is right, but in calculation you mistook it. Okay, no problem. You learn it.
Once I know that. So once.
Now see. First of all, what I told you. First of all, try to solve these combinations. Okay, and replace it with equivalent resistance. So for
So
this,
is it R? Overall R.
huh?
Is it R the answer?
Yes, answer is R. Right. Very good. Excellent. Okay. So that's how you do
Yes,
it.
sir.
For this, R equivalent will be what? 1 upon R plus 1 upon R, which is nothing but 2 by R. That means R equivalent is R by 2. So both the circuits are same. That means for this one also R equivalent will be R by 2. So new circuit will be what? R by 2, R by 2. And for this combination, equivalent resistance will be R by 2 plus R by 2, which is nothing but R ohm. Right? Now, any question?
Yes, sir.
You having
No,
any
sir. Thank you.
question? Okay. Are you enjoying the session?
Yes, sir. No question
Okay.
now.
Okay. Now let's talk a little bit about the potential current. Okay, in the series and parallel combination. Do you want me to change the color? Okay, because I'm using the same colors. Let's take this. This is a series combination. Okay. Series combination and parallel combination. Few things you need to remember. First of all, we'll start with the figure. In series combination, that's how the circuit look like. Okay, R R.
Yes.
And for parallel combination, that is how the circuit looks like. Here, this is R. This is R. Okay. So first of all, let's say we take one battery of potential V. So pardon me, I got a cold, so that's why my voice is not good right now.
Yes, sir. I also can relate.
Okay. So let's say the current is flowing in this direction. Okay. So for series combination, current remains same, right? And potential varies for the series combination. So for series combination, for this resistor, we can write it as V1 is equal to IR, right?
Yes, sir.
Okay. Let's take this as R1, R2, R1, R2. So this is V1 is equal to IR1. And for this R2 resistance, we can write it as V2 is equal to IR2, right? And from
Yes, sir.
here, we can write I is equal to V1 by R1. And from here, we write I is equal to V2 by R2, right? And we know
Yep.
that potential is nothing but the sum of V1 plus V2. Potential will
Yes,
be
sir.
what? V1 plus V2 or what? Yes. So from here, V1 is what? IR1. And from here, V2 is what? IR2. So we can take this I common. So what remains? R1 plus R2, right?
Yes, sir.
And send it to the left side. It will goes to denominator. And what is V by I? What is V by I? We know that V is equal to IR. By
Yes, sir.
sending I to the this side, we'll get resistance, right?
Yeah. Yes.
So that is how V by I is what? R equivalent. That's how we get the expression R equivalent is equal to R1 plus R2. Now understood how we add these resistors in series combination? Do you get it?
Yes, sir.
Okay, now let's talk about parallel combination. So we know that in parallel combination, potential remains same, right? Potential remains
Yes.
same, but the current get divided as I1 and I2, right?
Yes.
So for this R1, we can write V is equal to I1 R1, and for this R2, we can write it as V is equal to I2 R2, right?
Yes, sir.
Okay. Now we know that total current is I, and we can write total current I is equal to I1 plus I2, right?
Ah,
Okay. Any problem? Hello.
no, sir.
Okay. So from here, what we can write? I1 as we can write it as V by I R1 is equal to I1, and from here we can write it as V by R2 is equal to I2. Agree or not?
Yes, sir.
Okay. Now put these values in this equation. We will get V by R1 plus V by R2, and from V is equal to IR, we can write V by R is equal to I, right?
Ah, sir.
Okay, so instead of I, we are going to write V by R is equal to V by R1 plus V by R2. Are you getting my point? This is
Yes,
our
sir.
R equivalent. So this all V's will get cancelled out because they all are same, right? So
Ah,
1
sir.
upon R equivalent will be 1 upon R1 plus 1 upon R2. Clear? Any question?
Yes, sir. No, sir.
Okay, write this down. I'll be back in a minute. Okay? If I don't, I do not respond. Please wait for a minute.
Okay, sir. Yes, sir.
Done, Ishan?
Yes, sir.
Okay, let's move forward. Now let's take another example. The question says an electric lamp. Let me change it to red color. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6-volt battery. Calculate the total resistance of the circuit. Of the circuit. The potential difference across the electric lamp. The potential difference. PD means potential difference, okay?
Yes, sir.
Across the lamp and conductor. Want to try this question or let me just handle it by myself?
Sir, I don't think I'll be able to solve this one.
This one is easy or what?
No, sir.
It's so easy, brother.
One sec. Total resistance of the circuit. Okay, sir, yeah. It's easy. Sir, the total resistance will be 24 ohms, right? Because it's series.
Okay.
Is it 24 ohms?
Total resistance is 24 ohm. Move ahead. First of
And
all,
then,
whenever you solve the question, draw the diagram, okay? So you will not
yeah,
mistake anything. There is a lamp. There is one battery. Okay, battery of 6 volt. This is the conductor of resistance 4 ohm. Electric lamp whose resistance is 20 ohm. This electric lamp is having 20 ohm resistance. Okay?
yes, yes, sir.
Okay. So first of all, total resistance will be 24 ohm. Right. Now what is the total resistance? Okay. The current through the circuit we need to find. We need to find the current. So first of all, we have total resistance, total potential will be what? 6 volt. Agree or not?
Yes, sir. E equals to IR,
So
I
V is
equals
equal
to
to
V by R.
IR. I is equal to V
Uh,
by R. So
6
6
by
by,
24,
that means,
5 or 4.
so this is the current. Okay, next question was what? Calculate total resistance. The potential difference across the lamp and conduct. So potential difference between these 2 points A and B, and potential difference across these 2 points C and D, right?
Yes, sir.
This is the conductor. So that means potential difference between these is different and potential difference between the bulb is different. Because you know in series combination potential will be different, right?
Yes, sir.
So for this conductor we can write potential V1 is equal to IR1, right? Because current is same in both the cases. Current remains same in series combination, right? It is like a flow of river. Okay, there is no branches. So of course, river will flow in straight direction. So that is how current follows its path. Okay, straight line because there is no branches. Are you getting my point?
Yes, sir.
Okay, so the potential difference between this conductor, let's say these 2 points is conductor A to B, which is we take it as V1 is equal to IR1. We know I is 1 by 4 and R1 resistance is what? 4. So it is nothing but 1 volt. Now tell me, what will be the resistance across this lamp?
Uh, resistance across the slab.
Huh?
Sir, I have to 5 volts.
Sorry?
5 volts, sir. 5.
5 volt. How? Value of I is 1 by 4. Value of R2 is
Yes,
what?
sir.
20 ohm. But there is another way. We know that the potential difference here is what? 1 volt, right? Okay,
Yes, sir.
across the conductor it is 1 volt. Total potential is what? 6 volt.
Sir.
So if we want to find the potential difference across lamp, simply we can subtract these two from the total resistance. Total resistance is 6, total volt is 6 volt. So we can subtract this 1 volt from 6 volt. We can easily find this potential difference across this lamp because that is what it is using. Are you getting my point?
Sir.
It is the logical way, right? And we also know that V is equal to V1 plus V2. So that is how also we can write. We can find out V2 is equal to V minus V1. V1 is 6 volt and V1 is 1 volt and V is 6 volt. That means 5 volt. Easy?
Yes, sir.
Okay, write this down.
Yes, sir. Done.
Just a minute. Okay. Now let's do this question. In the circuit diagram given in figure 12.10, what is 12.10? Okay. The figure is given like this way. Okay. There is one bit. Resistance R1, R2, R3. So in given figure, suppose the values of this R1, R2 and R3 are 5 ohm, 10 ohm and 30 ohm, which have been connected to a battery of 12 volt. Connected to the battery of 12 volt. We need to find first the current through each resistor. Current through each resistor. Second, the total resistance. Okay, do it. Sorry. Do you think you can do this?
Sir, I don't think so.
No, brother, you are
Uh,
doubting yourself. This is the easiest one. Just try once.
yes, sir.
First
Sir,
of
the
uh,
overall current passing through each resistor is 40 amperes. Right, sir?
first of all, what is the total resistance?
Total resistance is 3 by 10.
3 by 10.
10 by
Let me check it.
10
Let
by
me
3,
just
sir.
do
10
it.
by
1 by R is equal to 1 by 5 plus 1 by 10 plus 1 by 30. We take
10
LCM
by
is 30.
30.
So
6
6
plus 3
plus
plus 1.
3 plus 1. So 1 by R is equal to 10 by
9 by
30. That means resistance R is 3 ohm. Total resistance, right?
yes, sir.
Now potential is given, which is 12 volt. So from V is equal to IR, we can write total current as V by R, which is nothing but 12 by 3, which is 4 amp. How much you are getting?
Sir, I made a mistake in the resistance. So,
How much resistance were you getting?
sir, I put 1 by 3.
Why? Okay. Okay, don't worry.
I made a mistake. I didn't take the reciprocal.
Okay. So now total current we know, but because of these branches, okay, current cuts in three different ways: I1, I2, and I3. And we need to find each of these currents. Okay. First of all, in parallel combination, potential remains same, right?
Yes, sir.
Now observe these things, what I'm talking, okay? These little points are going to make a change. Okay, these are the things that you need to remember, that in parallel combination, potential remains same, right?
Yes, sir.
Okay. So here for this R1 we can write V is equal, potential is same, V is equal to I1 R1, right? So I1 is equal to V by R1. V is nothing but 12 volt and R1 was what? 5 ohm. So first current we get it as 12 by 5. Second current will be what? 12 by 10, which is nothing but 1.2. And third current will be what? 12 by 30. How much? Hmm?
Uh, 1 by 15.
4
This
by
is
10,
12.
2
4 by
by
10,
5.
2 by 5.
So this will be the answer. Write this down. It was easy, right?
Yes, sir.
So don't make silly mistakes, okay? In calculation and etc.
Yes, sir.
Oh, write this down.
Yes, sir. Done.
Okay, let's move further. This question you need to do it, okay? All the questions are easy, brother. Just you need to remember these small things, okay? How potential behaves in series and combination, series and parallel, how current behaves. That's it. And ohms law. You're getting my point.
Yes, sir. Uh,
So question is this. There is one figure given like this way. This is the battery. Okay, now this is R1, this is R2, this is R3, R4, R5. The question says calculate total resistance. You need to find equivalent resistance. Okay, and then total current. That's it. Battery is 12-volt battery. Okay.
yes, sir.
Now find out total current resistance. Also find the currents in each resistance. This you are going to do in your homework. Okay.
Yes, sir.
You can take these names as this one as I1, I2, I3 as you wish. Okay.
Yes,
But
sir.
for now, tell me what will be the equivalent resistance. And okay, there is some data is given. Sorry, let me just write it. R1 is 10 ohm, R2 is 40 ohm, R3 is 30 ohm, R4 is 20 ohm, R3 is 60 ohm. Now do it.